In part 1, we looked at how to use like terms to complete all the squares. We used all the internal lines. This line gives us x plus y. Using this line, x plus y gives us 2x plus y. On this one, we have x plus 2x plus y for a total of 3x plus y. Coming up here, we've got x plus y and another y for a total of x plus 2y. This one here in the middle was a little bit tricky. We had to use a little algebra to realize that the boxes on the bottom have 3x plus y plus x for a total of 4x's and 1y. On the top we already have 1y. What we're missing are the 4x's. Now, continuing on, we have 4x plus 3x, which gives us 7x plus y. And this line gives us 7x plus y plus 4x would be 11x plus y. You'll notice that leaves one internal line we have not used. Today we're going to look at how to use that line to set up an equation that we can solve to then go back and complete this puzzle. So, on the left side of this line, we have two boxes touching that line. We have 11x plus y, and we have 4x. On the right-hand side, we have a box that has x plus 2y, and we have our original box y. Now, because those are on the same line, they are equal to each other, and by setting up this equation and solving it, we can actually figure out what the solution to the puzzle is. So, we go ahead and we can now combine the 11x with the 4x to get 15x, plus we still have the y. And that has to be equal to, well, there's just one term of x on the other side. We've got 2y and 1y for a total of 3y. Now the idea here is to get all of the x's on one side of the equation, everything else, the y's in this case, on the other side. We're going to do that first by subtracting x to get rid of this x. And one of the rules of algebra, of course, whatever we do to one side of the equation, we have to do to the other. Now remembering that x is just one x, if we have an x, we take away an x, we end up with no x's left, just 3y on the right side. 15x take away 1x gives us 14x, and we still have our original y. Continuing on from here, we can get rid of the y's on the left side, so we have all the y's on the right side. To get rid of plus 1y, we need to subtract 1y, and we have to do that on both sides of the equation. Those equals 0y, leaving us just 14x. 3 take away 1 leaves us with 2y. Now at this point we can simplify even farther, realizing that 2 goes into both 2 and 14. We can divide both sides of the equation by the same number, 2. 2 divided by 2 is 1y, and 14 divided by 2 gives us 7x. Now there are infinitely many solutions to the equation 7x equals 1y. We only need one, and we'd like to use the simplest one. So in other words, we need 7 times some number to equal 1 times some number. And, well, the easiest way to do that is to do 7 times 1 and 1 times 7. You see that that gives us a value of x is 1, y is 7. Using those numbers, we can now go back to the original puzzle, plug those numbers into our like terms, and we can figure out what number goes in each square. So, since x is 1, this square is a 1 by 1 square. This is a 7 by 7 square. Now, this one is x plus y, 7 plus 1. This square is 8. 2x plus y, 2x is 1 times 2 is 2, plus y is 7. That makes a total of 9. Up here we've got x plus 2y. That would give us 1 plus 2 sevens. 2 sevens is 14, add 1, this is 15. We got down here 1 plus 9 gives us 10. 4x, well, 4 times 1 is just 4. 7x plus 1, 7x is just 7, plus y is 7, this is 14. And 11x plus y, that's 11 plus 7, which is 18. What we can do now is use graph paper to take those numbers and draw the squares so the picture appears the way it actually should. For example, we have an 18 by 18 square here, we have a 15 by 15 square, etc., etc., and it all fits together perfectly, and this is the solution to the puzzle. This is how to fit a bunch of different sized squares into a rectangle. If you don't have graph paper, or you need to print graph paper of a custom size, for example with smaller squares so you can get this to fit, you can go to incompetech.com/graphpaper. They have lots of free options for you to print your own graph paper. So the idea would be to take the rest of the puzzles and see if you can use this technique to solve them and graph them. Good luck!